Hello, my dear future of country. Welcome back to our YouTube channel CK24. In this video, we will discuss the Cramer's rules, definition, how we apply to solve the simultaneous linear equations, and few questions we will solve. So let's get started. Here, definition. If the system of equations possesses a solution, then the equations are said to be consistent. If the system of equations has no solution, then the equations are said to be inconsistent. Right? Next, apply Cramer's rule to solve the simultaneous linear equation. We have a three equations. You can see on the screen a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2. Question 2, a3x plus b3y plus c3z equal to d3, that is question 3. So let us start to solve how. First of all, we let solution here. Let capital A1, capital B1, capital C1 be the cofactor of A1, small b1, small c1 dot dot in the determinant. Right? I think, and Cramer's have given the rule respect to determinant. Now we can write the above simultaneous equation here, that is D. D represent determinant, you know very well, and put in the bracket A1, A2, A3 column wise, B1, B2, B3 column wise, C1, C2, C3. It is A1, A2, B3 is the coefficient of X, B1, B2, B3 is the coefficient of Y, and C1, C2, C3 is the coefficient of Z. You know very well. Now multiplying equation 1, 2 and 3 by capital A1, capital A2, capital A3 respectively, and adding it, what we get. Let's see now on your screen this one. In bracket small a1 into capital A1 plus small a2 into capital A2 plus small a3 into capital A3 bracket close, and we write x here, plus b1 a1 plus b2 a2 plus b3 a3 bracket close, y plus c1 a1 plus c2 a2 plus c3 a3 bracket close, we write z equal to d1 a1 plus d2 a2 plus d3 a3 here written, right? Now we can write for x dx equal to d1 a1 plus d2 a2 plus d3 a3, and the column a1 a2 a3 we replace by d1 d2 d3. Then we write b1 b2 b3 c1 c2 c3, because here we have taken x, no, dx, determinant of x, right? So we can write like this one. We know that by the property of determinant, that we know very well, a1 capital A1 plus a2 capital A2 plus a3 capital A3 equal to d. Here we have written, and b1 a1 plus b2 a2 plus b3 a3 equal to c1 a1 plus c2 a2 plus c3 a3 equal to 0, right? So now we can write x equal to what? You transpose d in the right hand side, we will write 1 by d, and the determinant of x here we have written, right? Similarly we can do for the y. We multiply by b1 b2 b3 and adding it, and we get. Similarly, multiplying equation 1, equation 2, equation 3 by b1 b2 b3 and adding, what we get, like this one above, this one x equal to 1 by d, so we y equal to 1 by d, and we write the coefficient of a1 ax, a1 a2 a3, but the coefficient of y we replace by d1 d2 d3, and same as the coefficient of z we write here. Okay, as you can see on the screen, we get the y equal to that, and then last z equal to what we will write like above we will do, and we get this one, z equal to 1 by d, and in determinant a1 by a2 a3 b1 b2 b3 d1 d2 d3, right? So this can be written as, it can be written as like this one, x by determinant d1 d2 d3 b1 b2 b3 c1 c2 c3 equal to y by a1 a2 a3 d1 d2 d3 c1 c2 c3 z equal to z by a1 a2 a3 a2 here, here is a3, here is the b1 b2 b3 and c1 c2 c3. So what we have make mistake here, we will for z, here we write z equal to d1 by d2 and d3. In the place of c1 c2 c3 we write d1 by d1 d2 d3, right? So now let's see equal to what can we write, the determinants a1 a2 a3 b1 b2 b3 and c1 c2 c3. Obviously d is not equal to 0, otherwise the solution will be infinite. D is not equal to 0, so if not d is not equal to 0, that it will be infinite solution, right? So take the examples to understand. Here is the question in on your screen. You can see, solve the following equations by Cramer's rule. We have 2x plus 3y minus 3z. We can put the name 1. 5x minus 2y plus 2z equal to 0, equation 2. And 3x plus 7y minus 5z equal to 0, that is equation 3. So let's say start to solve. First of all, write the coefficient of the variable x, y, z in a determinant form. So we will write, it is the symbol of determinant, equal to 2 5 1 3 minus 2 7 minus 3 2 minus 5. Above we have seen that x equal to what we have written. Before that we will find the determinant of this one. Okay, so you are able to find the determinant of that. You take 2 here and bracket is start, then you multiply this one and this one. 5 to the 10 we have written 10, 7 to the 14 we have written 14. Minus it we get minus 4, and next we will write 3 here. For minus 3 you keep it constant. No, no sir, not keeping keeping it constant. So right now 3 minus 3, that is minus 25 minus 2. You are able to find the determinant, so not required to be explained here. Here is the for gate minus 3 into 25 plus 2 in a bracket, and after computing we get here 25 plus 2, that is 27, but it containing negative sign. Negative 25 plus negative 2 we get negative 27. Or here 35 plus 2 we get 37. We multiply 2 4 ja 8. Here is minus plus minus. We recall the integers property here. According to the properties of integers we are doing here, right? Negative 27 with negative 3 we get 81 plus, and here 37 into minus 3 we get 111. After compute it we get that minus 38. The determinant of this one is minus 38. Now let's start to apply the above which we have derived, right? So for x we can write 1 by determinant, and the determinant 0 19 5 3 minus 2 7 minus 3 2 minus 5. We can write 1 by negative 38, and in big bracket we write negative 3 here, negative 95 plus negative 10, what we get you can write here and solve it. You see here that one have written taken, that is 19 and that one and that one. This here 95, 95 yeah 95, and here is 5 to 10 we have written, or here we have taken for this one, no, right? So minus 3 and 133 plus 10, where it is, can you see? Yeah, 19 7 ja 133 and 5 2 ja 10. What, why it's become plus 10? Because minus and minus 10, we get 10, right? And the 3 is written here for this one. Okay, so you know very well. Next, minus 1 by 38, that come, calculate it and we get this one. Okay, minus 1 by 38 plus this one we get minus 114 divided by 38, minus plus, according to the integers rule, equal to 3. We get the x value 3. uh, Same as we can do here, right? For y, that one 251 0 19 5 minus 3 2 minus 5, can we write tell it? No. 251 0 19 5 negative 3 to negative 5, here is 1 by 38, we get the minus 38 or negative 38 we get. Write this one like this one and put big bracket here and calculate it, what we get 1 and 5, there is a 6, and here 1 by negative 38 negative 510 plus negative 18 we get 218. Then we get here negative 38 or negative 218, we get plus, so we get 6, y equal to 6 here. For z we will find here uh, like above we write this one for z, right? Here is the values, this is a values. Now as above we write here and calculate it, what we get here you can see this one and this one and this one. We have, when we have to add negative 286 negative 18 we get 304, negative, and negative 38 it's become plus, so we get 8. Respectively completed this session. What we get the value of x and y, here x equal to 3, y equal to 6, and z equal to 8. Like as we will apply the Cramer's rule and find the value of x, y, z of the given simultaneous equation. So that's it for today, my dear learners, my dear future of country.